My name is Mohammad Nazmi. I will be presenting the introduction to the Stuxnet worm attack of 2010, a cyber weapon unlike anything the world has seen before. Stuxnet wasn't just another computer virus, it was the first known malware to cause real-world physical damage by secretly sabotaging Iran's Natanz nuclear facility. It targeted Siemens PLCs, caused centrifuges to fail, and hit its track, all without being detected. This case raised major concerns about public safety, engineering ethics, and the misuse of technical expertise. The purpose of this study is to explore the technical flaws that made it possible and the ethical violations that made it dangerous.
I am Winnie, and I will be discussing on the topic of Stuxnet. In January 2010, Stuxnet used a stolen certificate from Realtek to sign its malicious driver, allowing it to install undetected components on Windows systems. By June 2010, researchers discovered the worm, which spread via USB drives, exploited zero-day vulnerabilities, and targeted Siemens PLC at Iran's Natanz facility, causing physical damage with a rootkit. In July 2010, Microsoft released a patch to fix these vulnerabilities, and VeriSign revoked the Realtek certificate. The next day, Stuxnet was found using a second stolen certificate from J-Micron Technology. On July 19, 2010, Siemens acknowledged the malware's impact on their SCADA systems, and later in September 2010, Microsoft released a second patch to address vulnerabilities in the Windows Frame Spooler service.
In 2010, the Stuxnet worm targeted Iran's nuclear facility and exposed serious technical and engineering failures. First, it took advantage of weak separation between IT and control systems. Just one USB drive allowed the worm to bypass network defenses and attack the industry operations. Second, the software had major flaws. Hard-coded passwords and hidden vulnerabilities gave the worm full access to critical machines with no one noticing. Third, the system lacked proper monitoring. Stuxnet faked normal readings while sabotaging centrifuges, showing the need for sensor backups and real-time alerts. And lastly, outdated software made things worse. Critical security updates were delayed, leaving the door wide open. The Stuxnet attack reminds us that engineers must design secure systems, validate software properly, monitor in real time, and always keep systems up to date.
My name is Nelly, and I'll be explaining the ethical issues of the Stuxnet case in regards to the Malaysian Engineers Act. One was public safety. Stuxnet was supposed to attack only systems within Iran's nuclear facility. However, a flaw in the code led to the attack of over 100,000 untargeted systems globally. This violated the engineer's duty to protect public welfare. Abuse of technical knowledge. Stuxnet fed false data to operators while damaging key systems within Iran's nuclear facility. This harmed reputations of all the operators involved in this nuclear facility, which goes against ethical expectations of engineers. Lastly, the lack of accountability from developers violated the breach of transparency. The developers did not disclose the risks to victims, and so they were left unaware and unprepared for this attack.
Hi, my name is Brendan, and I'll be presenting about the recommendations to prevent future incidents, or we call it preventive actions. Here are 3 strong points, which are the enforce strong OT/IT network segmentation, implement timely software updates and patch management, design with redundancy and real-time monitoring. To prevent attacks like the Stuxnet worms, engineers must take action, starting with stronger network segmentation. Critical systems must be isolated with strict access controls and firewalls between OT and IT networks. This isn't optional, it's our responsibility under Section 8 of the Engineers Act. Next, we must stop delaying software updates, as Stuxnet exploited systems that weren't patched. Timely updates and solid patch management aren't just best practices, they are a requirement under Clause 3.0 of the BEM Code. Lastly, we need to build smarter systems. That means redundant sensors, real-time monitoring, and anomaly detection. Stuxnets went unnoticed because they weren't in place. As engineers, we must design systems that can detect and respond to threats, because public safety is not negotiable.
In conclusion, the Stuxnet attack revealed just how vulnerable industrial systems are, not only in design but also in ethical oversight. It showed that technical knowledge can be weaponized when ethics are ignored. The malware spread beyond its intended target, caused global concern, and broke several principles under professional engineering codes. As we move forward into a world of smarter systems and deeper automation, engineers must not also be skilled, but need to be ethically grounded. Stuxnet reminds us that innovation without responsibility is a threat, not a solution. That's all from us. Thank you.